Okay, so this is the first part of the midterm review. There's not going to be a whole lot on this. I started a little bit late. I think I only missed the very first worksheet that was in the packet. So I think this will only be about a 10-minute video, if that. So this is the review packet. This is in focus. It's under the midterm review assignment. There's two attachments in there. One of them is the midterm review, and then one of them has to do with your semester grading scale based on your quarter one grade, your quarter two grade, and your midterm grade. So I'm not going to go over that second attachment. I'm just going to do the review in this. But if you have questions, you can get with any teacher and they can explain how your grade works. Obviously, you can get with me as well, and I will be happy to explain it to you individually. So here's the first page of the packet. So this was a long time ago, the very first thing we did, pretty much. It had to do with operations with irrational numbers and rational numbers. So I didn't focus a lot on problems like 6, 7, and 8, mainly because you were going to have a calculator and you would have been able to figure them out with a calculator without having to understand anything. So there was no point in even really trying to do them. So you're not going to have any questions like that from me. Now, next year you will, under EOC, you'll have to understand how to estimate these numbers. For example, 1/4, you need to know how to turn that into a decimal. And you need to know how to do that by hand, not with a calculator. Square root of 5, you need to understand how to estimate that as a decimal, which we did. We did all of that. We talked about how to estimate it. I'm just not putting it on the midterm because you're going to have a calculator for the midterm, so it would be too easy for you to do those problems. I'm going to focus on how to tell when a number is rational or irrational, and then what type of operations or what type of answers you get when you use rational and irrational numbers, depending on what type of math operation you do. So let's just talk about the way that we learn this. I didn't do a real mathematical way. I did more of a storytelling way. So if you'll remember, I talked about people being rational and irrational. Rational people, I said I was a rational person. Rational people like things to make sense, which you would think everybody does, but it was just an example, just a story I made up. So rational people like things to make sense. Irrational people, things don't always make sense with them. So that was the general definition we used for rational and irrational. So when it came to numbers, rational were numbers that made sense, or really answers that made sense. And then irrational meant that the answers didn't make sense, sort of. You'll understand as I go through. So I said, if I'm a rational person, Mr. Gill is a rational person. If I'm talking to another rational person who makes sense, so we both make sense when we talk, we're going to have a nice rational conversation that makes sense. So a rational person and another rational person have a rational conversation. Everything makes sense. Rational and rational gives you rational. So when it came to math, we said it's kind of the same way. If you have a rational number and another rational number, then your answer is going to be a rational number. It doesn't matter if you add them, subtract them, divide them, multiply them. None of that matters. It's going to be a rational number. Now, if you have an irrational number and a rational number, or an irrational person, I should say, let's do that first. If I'm rational, so I like things to make sense, but then I talk with somebody that's irrational. They're not rational. They are irrational. They don't make sense. The fact that they don't make sense is going to drive me crazy, and now I'm going to get all frustrated, and all of a sudden I'm going to stop making sense because I'm so frustrated, and now everything gets changed to irrational. So just the fact that now I'm talking to somebody that's irrational changes me from being rational to irrational. So again, we talked about numbers. It's kind of the same way with numbers. If you have a rational number and an irrational number, then that's going to create an answer almost always. Now, this case is not 100% of the time. Rational and rational is 100% of the time. Rational and irrational isn't 100% of the time, but it's almost 100%. So rational and irrational is going to create an irrational answer. Now, the one exception to that, I'm just going to show you real quick on the board. If I have an irrational number, so for example, the square root of, oh, is this not working? Try that with a different pen real quick. Try it again. So if I have an irrational number, there we go. So square root of 7 is irrational. And we're going to go over in a minute how to tell if something's rational or irrational. If it's addition or subtraction, it doesn't matter what number I add to that. If it's a rational number, for addition and subtraction, adding a rational and an irrational number is always irrational. The only exception is on multiplication and division. If there is one particular rational number that can turn this into a rational number instead of it being irrational. The only exception, that's a multiplication symbol, so the square root of 7 times 0. If I multiply that times 0, I get 0, which is a rational number. I could also say the square root of 7 and then say 0 divided by that. And again, that gives me a rational number because 0 divided by the square root of 7 is 0. So that's the only exception really, and it's only for multiplication and division, and it's the number 0. Any other rational number, whether it's addition, subtraction, division, multiplication, will give you an irrational answer. So rational and irrational almost always is irrational unless you're multiplying or dividing with 0. So now let's talk about how to tell if something is rational or irrational. I'm going to zoom in a little bit for this. Well, just going to put my pen down. We'll zoom in a little bit. Too far. I went too far. All right, so first of all fractions and all decimals are rational numbers. It's kind of the definition of a rational number. A rational number means it either terminates, or if it's a decimal, it repeats forever. Like there's a pattern to the repeating. You'll understand more hopefully as I go along. So any decimal, there's a decimal. That is a rational number. Any fraction, that is a rational number. Again, decimal, rational number. Decimal, rational number. All of those are rational numbers. If you don't have, and this is, again, not 100% of the time when they give you a district test, for my test it will be, if you have, the only time you have to even worry about it maybe being irrational, if it's a number, is if you have one of those type of symbols, a radical symbol. If you have a radical symbol, then you need to figure out whether or not it's a rational or irrational number. And here's the way you do that. If I take the number, so here we go, right there, that is 4/9 in there. If I take that, I can rewrite it, first of all, as the square root of 4 over the square root of 9. If I can get rid of those radical symbols, get rid of the square root symbols, then that number is no longer irrational. It becomes rational because I don't have this, I wouldn't have this symbol in there anymore. Well, I know the square root of 4 is 2, and I know the square root of 9 is 3, so that's actually the same thing as saying 2/3. And if you'll notice in 2/3, I don't have this square root symbol, this radical symbol. So therefore, this is a rational number because I can get rid of that rational symbol, that radical symbol, that square root symbol, by simplifying that down to 2/3. All right, well, let's look at some of the other ones that have that square root sign in them, radical sign in them. Well, here's one. Square root of 5. Is there anything I can do to get rid of that? Well, square root of 5 doesn't have any number that you can say this number times itself equals 5. So there's no way to get rid of that. So that's just square root of 5. So that's irrational. Oh, by the way, midterm is not open note. So if you're watching this, it's not open note. So you can take notes, but you got to learn how to do this on your own. This one right here, let's talk about that one. Again, I could rewrite that as the square root of 25 over the square root of 16. Well, again, I can reduce this. I can simplify it. I can get rid of those square root symbols because I know the square root of 25 is 5 and the square root of 16 is 4. So if I can change this whole thing into 5/4, then 5/4 is just a rational number. So that's a rational number. Now this one's a little tricky because you might think, okay, well, I'll just do exactly what Mr. Gill did. I'll change it to that. Well, there's nothing I can do with those. Square root of 12 doesn't have any perfect square root. Square root of 3 doesn't, so I can't get rid of that. So you might think, hey, that's an irrational number because I couldn't get rid of those square root symbols. Well, here's the tricky thing. Before you do all of that, if you'll notice, I could just take the 12 divided by 3 and make that 4. So I could just take this inside part, 12 divided by 3, and I could just make that 4. So really, that's the same thing as the square root of 4 if I do 12 divided by 3 first, and we know that is the number 2. So again, that is a rational number. So this is rational. So those are the different ways that you can try to test that. So here's a couple of examples down here, whether or not a math operation is rational or irrational. So if I look at these numbers, well, first of all, is that a rational or irrational number? Well, I can't do anything to get rid of that square root symbol. There's nothing I can do to the number 10 to get rid of that. That's just, so that means that is irrational. Well, 5 is just a rational number because there's no square root symbol in it, no radical symbol. So now I have an irrational number and a rational number. So we said if you have an irrational person and a rational person, the conversation winds up becoming irrational because the rational person gets frustrated and now everything goes irrational. There's no 0 involved, that's the only exception. So that means that has got to be irrational. Well, again, down here, let's look at this. Square root of 18 and 3. Well, we know 3 is rational because it's just a regular old integer. Square root of 18, is there anything I can do to that? Well, no, not really. Square root of 5 is, I'm sorry, square root of 25 would be 5. That doesn't help us. Square root of 16 would be 4. But the square root of 18 is in between. It's nothing. It's just an irrational number. So again, I have an irrational number and a rational number. Now there's no exception for this because we're doing subtraction. Difference means subtraction. So if this is the case, there's no exception at all, even if there was a 0 involved. Well, yeah, even if there was a 0 instead of a 3. So again, that is irrational. It says, can the sum of 2 irrational numbers ever be a rational number? That's a no. If you're dealing with addition and subtraction and you're adding 2 irrational numbers, it can never be a rational number. I didn't go over that in the face-to-face classes. I just saw it, so I thought I'd mention it. Then it says, can the quotient of 2 irrational numbers ever be a rational number? That's a yes, because you could take the same irrational number and divide it by itself, and you would get 1, which is a rational number. So again, It's a rare exception, but it is an exception. Pretty much any other time you deal with two irrational numbers, you're going to get an irrational number. Well, not any other time, but most of the time. There are more exceptions to two irrational numbers. That's why I'm not really going into it. So focus on all rational numbers. If all the numbers are rational, you get rational. If one number is irrational and another number is rational, then most likely you're going to get irrational unless the rational number happens to be 0. That's the only exception. And it's got to be multiplication and division for that exception to happen. Adding 0 doesn't change anything to rational. Because basically if I said this irrational number plus 0, well, that's still just the same irrational number. So that didn't change anything like it does with multiplication or division. All right, and that was really all we did that you missed. So that was part 1 of the review. Part 2 will also be up as well.